Hello and welcome to my science tutorials. In today's video, we want to look at word problems involving quadratic equations. So without further delay, let's begin. So we want to start by looking at an example. We have the length of a rectangular field is 30 meters greater than its width, W in meters. We have to write down an expression for the area, A in meters squared, of the field in terms of W, II. The area of the field is 8,800 meters squared. We have to find it with and perimeter. Okay, so this is very easy, very simple to do. Let's look at our solution. So we're told that the length of a rectangular field is 30 meters greater than its width, W. So we have the width of the rectangular field being equal to W in meters, and then we were told that the length of the field, is 30 meters greater than the width, so it should be 30 plus W. This should give us the length of the rectangular field. So we have to write down an expression for the area, that is for I. Now the area of a rectangle or a rectangular field equals the length multiplied by the width. So now that we know this, it means area is equal to our width, our length is 30 plus W, and our width is W. So therefore it means that our area, if we expand this bracket, we are going to get 30W plus W squared, and so this becomes the expression for our area. We have 30W plus W squared. Alright, now we have to find the area of the field. The area of the field is 8,800 meters squared. We have to find its width and the perimeter. So let's go ahead and do that. So we're told that area is equal to 8,800 meters squared, and we know that the expression for area that we had is equal to W squared plus 3 plus 30W. Okay, I just interchange the position of W squared and 30. So from here it means I have 8,800 is equal to W squared plus 30W. Now for me to be able to find W, I need to rewrite this whole equation to get my quadratic equation. So I send the 8,800 to the other side of the equal to sign. So I have W squared plus 30W minus 8,800 is equal to 0. So this becomes my equation that I need to factorize and get my answer. Now if I use the coefficient of the W squared term here, which is 1, to multiply negative 8,800, I get negative 8,800. Now which two numbers will I multiply to get negative 8,800? But if I add or subtract, I get the middle coefficient, which is 30 over here. Now apparently if you use 110 and 80, you can do that. So positive 110 and negative 80, if you multiply them, you get 8,800. That is negative 8,800. But if you add 110 and negative 80, you are going to get 30. So let's use that. So we have W squared plus 110W minus 80W minus 8800 is equal to 0. Right, so from here I can factor out W out. So if I do that, I have W inside bracket, then I have W plus 110, then I have over here minus, between 80W and 8,800, 80 is common, so I write my 80 into bracket, then I have W plus 110 is equal to 0. So from here I can have W minus 80, then W plus 110 is equal to 0. So therefore it means that W is equal to, if I send this to the other side of the equal to sign, it becomes positive 80 meters. If I send 110 outside, it becomes, or negative 110 meters. Now you realize that the width is either 80 on 110, but the width cannot be negative. because the width cannot be negative, it means that our W over here is equal to 80 meters. So 80 becomes our answer for W. Now, we're also asked to find the perimeter of the field. Alright, so to get a perimeter, we need to first find the width, find the length before we can go ahead and find the perimeter. So from here, it means that 30 plus 80, okay, which is 30 plus the width, will give us a total of 110 meters as the length of the rectangular field. So from here, we can go ahead and find our perimeter. Okay, so our perimeter is equal to, the perimeter of a rectangle is 2L plus 2W. So that means that we have 2 multiplied by our L, which we found is 110, plus 2W. The W is the width, which is 80 over here. So therefore, it means that we have 2 multiplied by 110 will give us 220, plus 2 multiplied by 80 will give me 160. Okay, so if I add the two, I get 380 meters as the perimeter for this particular rectangular field. So this is how we solve this type of question to get the parameters that we're asked to find. All right, let's have a look at another example to further appreciate what we're doing. So we have a cylindrical thing of height h centimeters and radius r centimeters, has a surface area including its top and bottom a meters squared. We have to write down an expression a in terms of r, h, and pi. I. A tin of height 6 centimeters has the surface area of 54 pi centimeters squared. What is the radius of the tin? And then I. Another tin has the same diameter as the height. Its surface area is 150 pi centimeters squared. What is its radius? Alright, so let's go ahead and try our hands on this problem. So we're told that a cylindrical tin has a height h centimeters and radius r centimeters, and the surface area includes both the top and the bottom. So the I is demanding that we write an expression for the area in terms of the radius, the height, and pi. Okay, now the area of a cylindrical tin which has both the top and then the bottom there and not removed is 2 pi r squared plus 2 pi rh. So this is the expression for the area of a cylindrical tin having both the top and then the bottom covered. So this is the expression for I. Now I, the tin of height 6 centimeters. So we have height is equal to 6 centimeters. Then a surface area of 54 pi centimeters squared. We're asked to find the radius, which we do not know. Alright, so let's go ahead and look at that. Now we know that the area is equal to 2 pi r squared plus 2 pi rh. Okay, so we're given the area to be 54 pi is equal to, then this we have 2 pi r squared plus 2 pi r. The h is 6, so we can do that substitution. So we have 54 pi here is equal to 2 pi r squared plus 2 multiplied by 6 will give me 12 pi r. So I continue over here. So from here I can decide to factor out 2 pi because 2 pi is common over here. So I have 54 pi is equal to, if I factor out 2 pi over here, I'm going to have 2 pi outside, then into bracket r squared plus this will give me 6r. Okay, so it means if I expand this bracket, 2 pi multiplied by r will give me 2 pi r squared. 2 pi multiplied by 6r will give me 12 pi r. Okay, so from here I can divide both sides by 2 pi. So this cancels this. So 54 pi divided by 2 pi. Pi will cancel pi. 54 divided by 2 will give me 27. Is now equal to r squared plus 6r. So I rewrite this equation. I have r squared plus 6r minus 27 is equal to 0. Now we can see our quadratic equation that we need to factorize. So let's go ahead and factorize this quickly. I multiply the coefficient of the r squared term plus the constant. So 1 multiplied by negative 27 will give me negative 27. Now, which two numbers can give me negative 27 if we multiply them, but if we add or subtract will give me a positive 6. So 9 and 3 will do that. 9 times 3, 9 multiplied by negative 3 will give us negative 27, but 9 plus negative 3 will give us positive 6. So let's use that. So we have r squared plus 9r minus 3r minus 27 is equal to 0. So from here, I factor out r. I have r outside bracket into bracket r plus 9 here, then minus 3 here into bracket r plus 9 is equal to 0. So I now have my factors to be r minus 3, r plus 9 is equal to 0. And so if I send these guys to the other side of the equal to sign, okay, so I have, let me make some small space here. I have r minus 3 is equal to 0. So therefore r is equal to 3, or r plus 9 is equal to 0, and then r is equal to negative 9 over here. Now, since the r we are finding, which is the radius, cannot be negative, it means that our r is 3 over here, which is supposed to be 3 centimeters. So the value for our radius in the II option is 3 centimeters. So the radius of the tin is 3 centimeters over here. Now let's go ahead and look at the II aspect of this question. So let me get rid of everything here. Okay, so I. They said another tin has the same diameter as the height. So we were told that the diameter is equal to the height in this case. Now its surface area, the area is equal to 150 pi centimeters squared. Now we're asked to find what the radius is. Alright, so now let's make some deductions over here. We were told that the diameter, which is I'm representing with D, is equal to the height, which is equal to h over here. I know that 2 times the radius will give me the diameter. So it means that 2r will give me the diameter, which is equal to the height. So it means that wherever I see height, I can replace it with what? 2r over here. So let's look at that. So our area, the expression for our area, we said is 2 pi r squared plus 2 pi r h. Now we have h over here, so I can replace it with 2r. So the expression for my area becomes area is equal to 2 pi r squared plus 2 pi r multiplied by 2r. So my area is now equal to 2 pi r squared plus, now 2 multiplied by 2 give me 4. Then I maintain the pi, r multiplied by r will give me r squared. Okay, now I can proceed to solve my answer. My area is 150 pi. So we have 150 pi is equal to 2 pi r squared plus 4 pi r squared. Okay, so from here I can decide to factor out 2 pi. So I do that. So I have 150 pi is equal to 2 pi outside bracket, then into bracket r squared plus, because I factored out 2 pi over here, I'll be left with 2r squared over here. So from here I divide both sides by 2 pi. This cancels this, this cancels this. 150 on 2 will give me 75 is equal to, over here I have r squared plus 2r squared, that will give me 3r squared. Okay, so from here I can divide both sides by 3, get rid of this. So r squared is equal to 75 on 3, that will give me 25. And to find my r is equal to plus or minus the root of 25, and then it means that my r is equal to plus or minus 5. So r is either positive 5 or r is negative 5, but we know that our answer cannot be negative since our radius is supposed to be positive. So it means that we are going to go for the positive value. So our r, which is our radius, is equal to 5 centimeters in this case. All right, let's go ahead and try one last example. Now we have when the first n positive integers were added together, their sum is given by half n into bracket n plus 1. We have to demonstrate that this result holds for the case n is equal to 5, and find the value of n for which the sum is 105. What is the smallest value of n for which the sum exceeds 1,000? All right, so let's go ahead and look at how to answer this particular problem. So our solution: I. We are to demonstrate that the result holds true for the case n is equal to 5. Now, when n is equal to 5, it means the maximum value over here for the positive integers is 5. So the positive integer starts from 1. So we have 1, 2, 3, 4, 5. Now we were told that if they are added together, their sum is equal to the expression over here. So let's see whether that is true. If I decide to add all the expression over here, 1 plus 2 plus 3 plus 4 plus 5. So 1 plus 2 will give me 3, 3 plus 3 will give me 6, 6 plus 4 will give me 10, 10 plus 5 will give me 15. So I have 15. Now let's see if we use the expression which is half n into bracket n plus 1, we are still going to get a 15 over here. So our n we're told is 5, so we do the substitution: half into bracket 5 and into bracket 5 plus 1. So this is equal to half multiplied by 5 multiplied by over here is 6. So this is equal to, I can rearrange this as half multiplied by 6 multiplied by 5. So this gives me half of 6 is 3, then multiplied by the 5, and this is equal to 15. So over here I can say that I have 15 if I use the value n, which is equal to 5, and I substitute it into this expression, I get 15. Now if I use the manual way and I add them by myself, I also get 15 at the end over here. So it means that the expression half n into bracket n plus 1 holds true. It holds true for n is equal to 5 as required by the question over here. All right, so let's proceed to find the value of n for which the sum is 105. So I. So we have to find the value of n, we don't know, for which the sum is equal to 105. So we know that the sum of these n positive integers is equal to half n into bracket n plus 1. All right, so we're told that the sum is 105, then this is equal to half n into bracket n plus 1. Okay, so we have to find n. So the first thing we need to do over here is to get rid of this fraction. We can do that by multiplying both sides by 2. So 2 multiplied by 105 over here is equal to 2 multiplied by half n into bracket n plus 1 over here. So 2 multiplied by 205, that will give me 210 is equal to, this cancels this, so I have n into bracket n plus 1 over here. So I can now write 210 is equal to n multiplied by n will give me n squared plus n multiplied by 1 will give me n. So I can rearrange this equation to get my quadratic equation. So I have n squared plus n minus 210 is equal to 0. Alright, so from here all I need to do is to factorize this expression to get my answer. Now 1 multiplied by negative 210 will give me negative 210. Now which two numbers will I multiply to get negative 210 but add or subtract to get negative n over here, positive n, sorry. So if I look at it very well, 14 and 15 can help me. So positive 15 multiplied by negative 14 will give me negative 210, but positive 15 minus 14 will give me 1, which is the n over here. So let me use that. It means I have n squared plus 15n minus 14n minus 210 is equal to 0. So if you look at this, if I multiply 15 by 14, I get negative 210. But if I add this, I get just positive n. So it means I have not done anything at all to this equation above over here. So from here, I can go ahead and factorize this equation. So I factor out n over here. So I have n plus 15 here minus over here 14. Then into bracket, I have n plus 15 as well over here. So I can now say my n minus 14 over here, then n plus 15 is equal to 0. So it means I have n minus 14 is equal to 0, n plus 15 is equal to 0. So my n is either equal to 14 or my n is equal to negative 15. Now we know that n is a positive integer, so we are not expecting a negative integer as our answer. So therefore it means that the value of n for which the sum is 105 is n is equal to 14. Okay, so let's go ahead and try the last aspect of the question. So they said, what is the smallest value of n for which the sum exceeds 1,000? So this is going to be pretty interesting. So let's get some space and continue. Alright, so I. What is the smallest value? Now note, they are asking for the smallest value of n. Smallest value of n for which the sum, okay, exceeds or the sum is greater than 1,000. So let's look at that. So we know that the sum is equal to a half n plus 1. Okay, now if we want the sum to be greater than 1,000, let's use 1,000 to get the value of n, then see the closest value of n that will be greater than 1,000. So to do that, we said 1,000 here is equal to half n into bracket n plus 1. As usual, I multiply both sides by 2 to get rid of the half I have over there. So I get this expression. So 2 multiplied by 1,000 will give me a 2,000 is equal to n into bracket n plus 1. So I have 2,000 is equal to n squared plus n, and this gives me n squared plus n minus a 2,000 is equal to 0. Now if you look at this expression, 1 multiplied by negative 2,000 give me negative 2,000. But which two numbers will I multiply to get negative 2,000? But if I add them, I get a negative n. Apparently there's no number that can give us this particular answer. So we are going to use another method. Instead of factorizing, we'll use the quadratic equation. So the quadratic equation, n will be equal to minus b plus or minus the root of b squared minus 4ac all over 2a, where my a is equal to the coefficient of the n squared term, which is 1. The b is equal to the coefficient of the n term, which is also 1. And then the c, which is the constant, is the coefficient, is this value over here, the last value, so it's negative 2,000. Alright, so let's do the substitution and see. So our n is equal to minus b will be minus 1 plus or minus the root of 1 squared minus 4 into bracket a is 1. So 1 multiplied by negative 2,000 will still be negative 2,000 here. Okay, all over 2, and a is still 1. So our n is equal to minus 1 plus or minus the root of this will give me 1 plus 8,000 over here all over 2. And so this is equal to n is equal to minus 1 plus or minus the root of 8,001 all on 2. Okay, so from here I can go ahead and find the value of n. So let me grab my eraser and get some space over here. Okay, so from here I can decide to do two things. I have minus 1 plus the root of 8,001 on 2, and that will give me, if I simplify this in my calculator, minus 1 plus the root of 8,001 on 2 will give me 44.22, or minus 1 minus the root of 8,001 on 2. If I simplify this expression, this is n2, let me make this n2, this is n1. If I simplify this expression in my calculator, it's going to give me negative 45.22. Now, from these two answers, we obviously know that we can go for the negative answer, and so our right answer in this case is 44.22. But now note, the question is asking what is the smallest value of n for which the sum exceeds 1,000. Okay, and we are getting 44.22. So it means that the correct answer is supposed to be greater than 44. The next integer after 44 is going to be the right answer. Okay, so let's test that out. So if n is equal to 44, let's see what we are going to get. So if n is equal to 44, we are going to get the sum to be equal to a half multiplied by 44 multiplied by 44 plus 1, and this will give me 22 multiplied by 45, and this is equal to 990. So it means that n has to be greater than 44 as an integer. So let's test if n is equal to 45. Let's see that out. So the sum will be equal to a half multiplied by 45 multiplied by 45 plus 1, and this is equal to a half multiplied by 45 plus 1 is 46. Then I bring the 45 here. So this is equal to half of 46, that will give me 23, and 23 multiplied by 45 will give me a total of 1,035. So 1,035 is definitely greater than 1,000, and so our correct answer is n is equal to 45 over here. So thank you so much for watching. This is some application or some word problem that involves the application of quadratic equation. Thank you so much for watching, and I will see you in the next video. Bye bye.